everyone, hope you're fine and you're safe at home, and I hope that you could understood all the videos I have uploaded so far. So you have not subscribed to our channel, please do subscribe it. So far we have discussed about the EMF of a cell, the internal resistance of the cell. What is meant by EMF? What is meant by potential difference? So many things we have discussed, right? So in this video, we are going to discuss about the combination of the cells. Likewise, we have studied the combination of resistors, combination of capacitors. Here we are going to study about the combination of the resistors. Why we are going to study about the combination of the resistors? Usually the cells we are using, it will be having a very small potential, that is it may be 1.5 volt or that is EMF value will be 1.1, 1.5, 3 volt like this. Okay. So, but in our machines we need higher energy. Okay. That means when the potential is high, the energy will be high. Okay. If you need higher energy, that means if the potential is high, the energy, that is the pushing of the charges may also becomes high. Okay. So based on the necessity, or in our machine sometimes we need higher potential. Okay. So that means at the same time we need higher energy. Okay. For that we need high current or high current. Okay. For that we will modify the that means if you want to increase the current, we have to arrange the cells in some other combination to increase the current. Okay. So we know that the power is equal to VI. Okay. This we already discussed. Okay. So in some machines, if it is so powerful, so what it will be having? It will be having high potential and it will be having high current, so that the machine will be powerful. Okay. We will be using that mobile battery. Okay, mobile battery, it will be having around of 3 volt. Okay, if you are using laptop, it will be consuming 30 volt. Okay, likewise some other machines, it will be consuming some other voltage or some other potential. Okay, so based on these demand, okay, based on one machine ko over madri or adoda power ke etta madri, it will having the potential will vary. Okay, so we have to change that is we have to design the potential. Okay, for that we are studying the cells in series and cells in parallel. So according to the power it consumes, sometimes we may need high potential or sometimes we may need high voltage. Okay, so for that, to design such a machines, okay, so we are combining the cells. Okay, there are two combinations. One is cells in series and the other one is cells in parallel. Okay, so first let us see cells in series. Okay, so this is the cell. We know that this is the symbol of a cell. Okay, here we have taken 3 number of cells connected one after the other. Series means what? Connecting one after the other. Okay, here the positive, negative of the one cell is connected to the positive of next cell. The negative of one is connected to positive of one cell. Then it is connected across the resistor. Okay, now let us see what happens if we connect it in series, whether the current increases or whether what about the potential, whether it will be increasing or it is not changing. That we are going to test it now. Okay, so this is the series connection of cell. I have taken only 3 number of cells. Okay, it may be n number of cells. Okay, so let us take, for our sake, okay, for our convenience, we are taking the EMF of all the cells as same. Okay, let us say EMF of the cells as psi. Okay, already I told you that it is denoted by the letter psi. Okay, so the first cell, it is the EMF is psi, second EMF is psi, third also the EMF is psi. Suppose a charge is moving from this position to this position. Okay, initially it is having 0 potential. When it crosses this cell, it has spent an energy of epsilon, that is psi. Okay, so here the potential is psi. So when it crosses here, the potential is psi plus psi. Okay, 2 psi. When it crosses here, 3 psi. So if we are connecting n number of potential, what will be the total EMF of this circuit? So the total EMF of the battery. Okay, so when the cells are connected, combined together, it forms a battery. Okay, so here the total EMF of the battery is combining all these EMF. So what will be the EMF? If there are n number of, 1 means 1 side, 2 means 2 side, 3 means 3 side. So if you are connecting n number of cells, the total EMF will be n psi. Okay, the total EMF, it will be N into psi. Understood? The next thing, this is the first one. The next thing is total resistance in the circuit. Okay. So here we are connecting a resistance across these cell. Okay, 3 cell எடுத்து series connect பண்ணிருக்கோம். Just to imagine, okay, cell battery cell இருக்குல்லையா remote லலாம் இருக்குல்லையா cell அதை எடுத்து series connect பண்ணிக்கோங்க using a copper wire. Okay, then you connect it with the resistance. Resistance is nothing but it is a load. It may be a bulb, it may be a fan, it may be a whatever may be. Okay, this is the resistance. So what happens? Total resistance in the circuit. What is the total resistance in this loop? Here there is a resistance of R. Only this resistance? Is there any other resistance? Yes, definitely. We know that in each cell there will be internal resistance. Okay. So here there will be internal resistance smaller. Here also internal resistance R. Here also internal resistance R. So what will be the total internal resistance? So here they are connected in series. Yeah, in the resistance are connected. Series are. So what will be the total resistance? It is nothing but R1 plus R2 plus R3. So what is that? If there are n number of resistors, what will be right? This is nothing but n into R. புரியுதா? இந்த resistance plus இதுல இருக்கிற எல்லா resistance எல்லாமே series connect பண்ணிருக்கிறதுனால we will write R equivalent as R1 plus R2 plus R3 up to Rn. So we can write it as n into Rn. Okay, that I have n into R. Okay, that I have written here n0. புரியுதா? Resistance. Okay. Then, what about my current now? Total current is equal to, we know that current is equal to potential by resistance. Okay, so total EMF by total resistance. So what is my total EMF here? It is N psi. What is my total resistance here? N plus N0. So this is the current in the given circuit, or if the cells are connected in series, the total current will be this one. Okay. Now, what I am going to do is, I am going to test. Okay. In the series connect பண்ணிருக்கேன் single ஒரு cell எடுத்துக்கிறேன். Okay. Single ஒரு cell வைக்கிறதுக்கும் series connect பண்றதுக்கும் என்ன difference? Whether the current increases or decreases. That I am going to test it. Can you understand? Series cell connect பண்ணிருக்கேன் ஒரு single cellையும் எடுத்துக்கிறேன். So single cellக்கு என்ன current? Series connect பண்ணா எனக்கு என்ன current கிடைக்குது அப்படிங்கறத I am going to test it now. Okay. So to test that, I am considering two cases. Okay. First case, I am considering the external resistance. This is the external resistance, bulb or whatever may be. Okay. This external resistance is much greater than the internal resistance. Idoda resistance, in the moon resistance vida romba high ah irukum appadinu consider pannom. Okay. For that, I can write I is equal to, since R is much greater than, that is external resistance is much greater than the internal resistance, I can neglect the internal resistance because it is very small. I can neglect the internal resistance. Okay. So I can write it as N psi by, I can neglect the internal resistance. So this becomes R. Okay. So what is my current now when the external resistance is very high? It is N psi by R. This is for series. Okay. Series connect பண்ணும்போது என்னோட current இப்படி இருக்கும். Okay. எந்த கேஸ்ல external resistance maximum இருக்கும் போது. Suppose I am taking for single ஒரே ஒரு cell எடுத்துக்கிறேன் அப்படினா what is my resistance? Psi by R. Okay. If I am taking only one cell, it is, we know that I is equal to EMF by resistance. Psi by R. That's all. Okay. So now you compare both this. When I am connecting in series, it is when I am taking a single cell, it is psi by R. But when I am connecting in series, my that is my current is multiplied by n. Evlo number of cell connect பண்ணிருக்கீங்களோ அந்த நம்பரால it is multiplying. Okay. So what happens to my current? Yes, my current will be increasing here. Okay. What about my current? It is increasing here. Okay. Then come to the next case. I am considering that the external resistance is very much smaller when compared to the internal resistance. Now what can I do? I can neglect the external resistance. Okay, R can be neglected. So right, for series, R can be neglected. So I can write it as, I can neglect this R. So this becomes N psi by N0. Okay, N and N get cancelled. When the cells are connected in series, now my resistance is psi by R. Write it for single. If I am taking only one cell, ஒரே ஒரு cell எடுத்துக்கிறீங்க அப்படினா, that also it is psi by R. Is there is any change in current? There is no change in current. Okay. So here the current doesn't change. Okay, the current doesn't change. Understood? புரியுதா? So cells சீரிஸா கனெக்ட் பண்ணும்போது ரெண்டு கேसेस வச்சு நம்ம அனலைஸ் பண்ணோம் இல்லையா? இதுல செகண்ட் கேஸ் பாத்தீங்கன்னா என்னோட எக்ஸ்டர்னல் ரெசிஸ்டன்ஸ் விட இந்த ரெசிஸ்டன்ஸ் ரொம்ப கம்மியா இருக்கிற நேரத்துல எனக்கு கரண்ட்ல எந்த சேஞ்சும் இல்ல. So when the external resistance is very less than the internal resistance, connecting these cells in series is waste. There is no advantage of connecting these cells. இங்க ஏதாவது advantage இருந்துச்சா நமக்கு எந்த advantageம் இல்ல. current increase ஆக போறது இல்ல. Okay, so when the external resistance is greater than the internal resistance, yes, the current is increasing. Okay, so when in this series connection, connecting the cells in series, when this is very small, it is of no advantages. Okay, so finally we can say when the cells are connected in series, here we can see the total EMF. What happened to my total EMF? It is getting increased n times of the EMF. Okay, so the total EMF, it is increasing. When I take the resistance also it is increasing. Okay, the resistance, it is increasing, it is added up. Okay, so in the resistance it is increasing. When we see the current, it increases when the external resistance is large, and it decreases, it doesn't change when the external resistance is low. Okay, so that's what when we are using motorcycle. Okay, in motorcycles we will be using a 12-volt battery. So in that, for that we are not connecting the cells in series. Chinna cells for 12-volt battery. If I am taking 1.4-volt cell, okay, I need 8 cells. Okay, if I am connecting in series, I can get 12-volt, but I cannot by using that cells in series, I cannot start my motorcycle. Okay, why? Because if I am connecting in series, then compared to the internal resistance, okay, my external resistance is very small. So what happens? It will not, there is no change in current. Therefore, my motorcycle doesn't move. Okay. Hope that you could understood this video. In the next class, we can discuss about the cells in parallel. Thank you for watching.